we do these, we call this the 5 summary numbers, the numbers that allow us to build this graph. So we're going to work on that a little bit. I'm not going to dwell on this too much, but we are going to work towards getting there. We do have a formula to find where your outliers are. Remember I told you we would get to that before the end of the chapter? So we do have a way to find out. We're going to do your quartile, and we're going to do your box and whisker at the same time, because it kind of works the same way. So let's take a look at this. If you take the data from the first one, just follow along with me, because a lot of it we don't really have to work out, we just have to kind of read. So if you look at page 102, these are the number of nuclear plants in the top 15 nuclear producing power plants in the country, in the world, are listed here. And they want you to find the first, second, and third quartile. Now, technically, if you put them in order from lowest to highest, you work your way in, you find your middle, that's your mean. That's our median, halfway through. Then, if you take the first half, work your way in, find the middle, that's your first quartile. If you take the second half, work your way in, find the middle, that's your third quartile. But we love our calculator a little bit better. So we put it in our calculator, and we're going to let our calculator give us all this information. So we don't have to do all that there stuff. So we're going to go to example 2. We're going to put this data into your calculator. So kindly put this data in your calculator.
So example 2, you said?
We're example 2. You're putting that data in your calculator. We don't have to do it by hand, but that is how it would work by hand. But we are going to do this one. So you're going to put this in your calculator, and we're going to take a look at this. Put it in your L1, and let's sort it. Just sort it in your L1 and make it look a little bit nicer. Hopefully mine's going in. My calculator hasn't been cooperative today. After you entered the last one, you should see a 26 for the next one, because you have 25 pieces of data. So everybody get this in here? Okay, do a one-bear stat on this, or sort it. Let's sort it first. Okay, so sort it and do a one-bear stat. No frequency, black out the frequency. Now, when we do this, we need quartiles, we need the percentiles. So we really don't need the mean for this. But you're going to scroll down till as far as you can go. Right there. These are called your 5 summary numbers. same as them, or did I do this wrong? Okay. These are called your 5 summary numbers. This is what divides it into quartiles. It gives you your minimum, your maximum. So we're going to put this on a number line right now. What's our lowest number? 19. What's our highest number? 46. So we have to go from 19 to 46. And we can even go, let's go from 15 to 40 to 50. So we probably can go by 5s in here. So see if you can space it by 5s. This is going to break us down to our data. We're going to build the box and whisker right from here. Page 102, was it? 102? 103. The median is technically your quartile 2. 25% of your data in quartile 1, 1 quarter. 2 quarters, you have 50% of your data. 3 quarters, you have 75% of your data. So this is sectioning this into 4 quadrants. Where there's one of these, just put a dot. Like at the 19, come above this, put a dot. At the 27, come above this, put a dot. You don't want to sit it on the line. At the 33, put a dot. At the 40.5, put a dot. And at the 46, put a dot. The easiest way to look at this is a box and whisker. So the middle 3, we're going to make a box. And we're going to bring out the whiskers. This is the middle of your data, right there. That quartile 2 is half of your data. Now sometimes your box and whisker is very skewed depending on where your data falls, which is why I wanted you to sort it. So you can kind of see if you have 25 entries, and I divided that by 4, right? About 6 pieces of data per quartile. You can kind of look at your numbers that way and say, well, are they close together? Are they far apart? And you can look at your box and whisker graph. So if this is quartile 1, this is 2, this is 3, this is 4. Which one has the least amount of variability? Which of those sections is the closest, is the shortest? 2 or 4, right? 2 or 4 is the shortest section. Now, if we took your data, if we wanted to do this far, and we wanted to go to your data, we could go to your data, whoops. If we counted we said 25 pieces divided by 6, divided by 4, so like about 6 each, we could kind of see where the variability goes in your data. So the second section, if we went down 6, 1, 2, 3, 4, 5, 6, and we started here at the 26, 27 area, look how much closer those are. A lot closer. Look how many 26s and 27s fell in there. Even in the last one, the last quadrant. This one looks like it's the biggest one. Either the first or the third is the biggest variability. But towards the end, again, look how close they are. Okay? They're getting a little closer in their data. So a box and whisker kind of lets us look at our quartiles. We also have what we call an IQR. This is an inter-quartile range. The easiest way to find this is when you're in your calculator and you did your one-var stat, and you go down to your 5 summary numbers, Which ones had the Q's? Q, Q1, Q3, right? Those are the only ones with the Q's. So interquartile range says Q3 minus Q1. It's got the word quartile. The only quartiles you see up there, we know the median is quartile 2, but it doesn't say it there. The only quartiles you see is Q1, Q3. Now if I subtract Q1 minus Q3, I get a negative number, right? So I have to subtract Q3 minus Q1. This is my IQR, my interquartile range. This is also going to tell us if we have any outliers. Okay? We do the outliers in 1 second. Are we okay with the interquartile range? That's the only reason I can figure why they're using box and whisker. Because we really don't use a box and whisker, but we use the concept of their quartiles, and we use the concept of percentages, all in here, all put together. So I am jumping, of course, to using this to find an outlier. So if you jump to page 104, we're doing this on all one set of data, and then we're going to try it again. If you look at where the guidelines are, and did I hand out your note page for this? Yeah, it's in your note page as well. I put it right here under your interquartile range. You're going to find your interquartile range. You're going to take this. So quartile 3, did anybody write that down? Quartile 3? 40.5? Well, I told you my board is not cooperating today. Do you believe this? Minus what's my Q1? 27? Thank you. So if we subtract this, what do you get? Ah, Chris, you're on it. Thank you. You're on it with me. Good. It's a good day. Every day is a good day. Okay. Now, if we multiply this number, 13.5, by 1.5, you're going to get, so multiply this for me, 13.5 times 1.5. What do you get? 20.25. So now, we're going to take this and we're going to subtract. We're going to multiply this. We're going to subtract your 1.5 times this value from your quartile 1, and we're going to add it to your quartile. It should say quartile 3. I think there's a mistake there. It should say add 1.5 to quartile 3. I think I have a mistake there. You see on your note page, number 5, it should say add 1.5 times your interquartile range to quartile 3. In other words, we're going to subtract it from this guy. We're going to add it to this guy. And we're going to see what piece of data it goes to. Anything that goes beyond that is considered an outlier. So subtract it from quartile 1 and add it to quartile 3. And let's see what we come up with. This is another reason why I had you put your data in order. Quartile 1 is 27 plus 20.20 minus 20.25. So this is going to be 6.75. Do we have a number that's less than 6.75 in your data? No, our minimum was 16, 17 somewhere, right? Our minimum was in the teens. So there's no outliers up front. Now we're going to take your quartile 3, which we have here, 40.5, and we're going to add 20.25, and we're going to get 60.75. This is where we're looking. Do we have any data past that point? So technically we have no outliers. No outliers in this. And we can kind of see once we sort it that we didn't have any outliers, right? Our data was pretty much close together. sometimes you get a number that is a little separate from the rest of your numbers, but not far enough to be considered a true outlier. So this is a good way to tell. We're going to do another one together and make it make a little bit more sense. I want to find one that's going to have an outlier. I think they have one. If you change that quartile 3, that's -3. Okay, so let's look at example 3. Example 3 says go back to the information in example 1. So go to the information in example 1 and put that into your L1 from example 1. Wait, hang on. Yeah, go back to example 1. This way it's not a lot of information. Go back to example 1 and put that information into your calculator. Period 1, my calculator was literally, I type it in here, jump over there, disappear. I'm like, what is going wrong with this thing today? But I think it's my whole board just acting up. I think it's my control board. Okay, put your data in, and they actually have it in order, so you're pretty good to find it in order. We're going to do everything with this one. Some pieces of data, hopefully. All right. Everybody got their data in? Do a one var stat. Remember, there's no frequency. Now, come down to your last 5 numbers. So we're going to say we have a minimum of 6, a quartile 1 of 9, a median. Median is the same as what? What quartile? 2, good. And we have a max. Now, when we put this on our box of Whisker graph, obviously which one stands out of all that data? If you look at their data, look at the book's data, 104 clearly stands out as an outlier. So let's calculate your interquartile range for this. It's quartile 3 minus quartile 1. So quartile 3 is 33, minus quartile 1 is 9. So when we get this, we get 24. If we take 24 for interquartile range, the only 2 Q's you see out here. Take the 2 Q's. If you subtract them backwards, you get a negative number. It's not going to have a negative. And it doesn't matter because it just goes the opposite way. So if we take this number and we multiply this by 1.5, tell me what you get. 36, good. So now, take your quartile 1 and subtract 36, because if you think about it, here's your quartile 1, right at the beginning of the box, and here's your quartile 3, right at the end of the box. So if we subtract, we want to see how far out do we go that way. If we add to quartile 3, we want to see how far out do we go that way. So we're going to take quartile 1 plus 36, so 9, oh, sorry, minus 36, we get a negative number. Did we have any negatives out there? So, did we have any outliers on the left side? No. We're going to take quartile 3 plus 36. Quartile 3 is 33 plus 36. We get 69. Did we have any numbers greater than 69? Yes. Which one? 104. So 104 is our true outlier. Question, John?
What did you do up there? 9 minus 36?
9 minus 36.
Alright.
Sorry. The reason we do subtract up here is, let this make sense. Like that's where I like to draw the box and whisker. Quartile 1 is here. So 36 away from here means I have to subtract it. 36 away from here means I have to add it. So when I come this way, I'm going to subtract 36. When I go this way, I'm going to add 36. That's why the box and whisker is helpful to look at when doing this, because it kind of makes sense. It does section your data off. It gives us quartiles. It gives us a better feel for where's the middle of our data and where our outliers go. I just didn't graph this in your box and whisker, because this would be way, way, way off to the side with the 104. But your interquartile range helps you find any true outliers. And we know that outliers have an effect on your data. Okay, it's kind of making sense? Kind of making sense. Okay, so we are gonna, I don't want to do percentiles till next week. I kind of want to get the box and whisker graph down. Let me just give you once you try that first time here. Okay, turn to page 109. 109, number 11. Page 109, number 11. I want you to make me a box and whisker graph. I want you to find me any outliers. Okay, 109, number 11. It should make a nice little box and whisker graph, and I think there is an outlier. Range. So my interquartile range says take the two Q's that are there. Q3 minus Q1. 63 minus 57. So my interquartile range is 6. Take 6 and multiply it by 1.5. What do you get, 9? Now what do I do with 9? Subtract it from quartile 1 and add it to quartile 3. So if I take quartile 1, 57, and I subtract 9, that would be 48. Do I have any data entries lower than 48? That side's good. If I take quartile 3 and I add 9, I get 72. Do I have any data larger than 72? Which ones? 80. 80 is an outlier. It didn't look like it, but yeah, when we did the graph, didn't it really drag my graph out? It really really dragged my graph out because even though 80 was not very far away from those 70s, it made a big difference because the rest of those numbers were so close together. So on Monday, we're going to pursue the rest of this.